Hello again out there in remote learning land. Today we're jumping into the properties of the atmosphere. It's a pretty amazing place, and it seems so high, right? I mean, you go up in an airplane, you're barely up in the atmosphere at all. But if you take the whole size of the Earth compared to the atmosphere, they say it's like paper, like the thickness of a piece of paper. So it's pretty amazing, even though you can go, 80, 90, 100 miles up. Compared to the Earth, it's nothing. But anyways, hopefully you've been working hard on those do now questions. Let's jump in. All right. Want to start out with a great clip from a movie, a little Iron Man action. He's battling the Ironmonger. I want you to take notice of what happens as they increase altitude. Why does that happen? Okay, check it out.
How do you think the Mark I chess piece is going to hold up?
It's 48% power and fall, so that chess piece was never designed for sustained flight.
Keep it posted.
Tupper.
Tommy! Tommy, are you okay?
I'm fine.
Obadiah, he's gone insane.
I know. Listen, you better get out of
Hold
here.
still.
Get out of here.
Where do you think you're going? The services are no longer required. Collateral damage, Tony.
Divert power to chest RT.
Power reduced to 19%.
Nothing is going to stand in my way. Least of all, you. It's impressive! You've upgraded your armor! I've made some upgrades of my own!
Sir, it appears that this suit can fly.
Duly noted. Take me to maximum altitude.
With only 15% power, the odds of reaching that are...
I know the math. Do it.
Sir, you're not going to read this. I think it's back.
Get me Major Allen. Scramble the jets.
Not necessary, people, just a training exercise.
Power, sir.
Climb!
11%.
Keep going. Leave it on the screen. Stop telling. should solve the icing problem.
Icing problem.
Might want to look into it.
Woo! What a scene, folks. What a scene. So there they are. They're heading up in that first layer of the atmosphere, right? We call that the troposphere. And as they're getting higher and higher, you notice the temperature is getting colder and the ice starts forming on the Ironmonger's suit. And the next thing you know, it just gets too cold and he starts to malfunction. As we go higher and higher, there's less pressure, but there's also temperature drop in the troposphere. And that, of course, caused a major malfunction in the Ironmonger there. Anyway, let's delve into the layers of the atmosphere here. Okay. And here is the classic chart from the reference tables. And we want to talk about the three most important variables that determine weather. Well, there you have it, folks. Jot them in. Temperature, pressure, and water vapor in particular. And you can see them right here. Temperature, pressure, and water vapor. Okay? The temperature zones we're talking about, we live in the troposphere. That's where that scene just took place, right? They went higher up in the troposphere, but that's it. They didn't go beyond that. And then the next layer up would be the stratosphere, and of course mesosphere and thermosphere. The in-between, the boundaries, the interfaces of the layers end with the word pause, right? So tropopause, stratopause, mesopause. There is no thermopause. That's where the blue meets the black, right? That's where you head into outer space, all right? Those are called interfaces, okay? All right. Other words for elevation, they're over here. You have altitude and, of course, height above sea level. Other ways of saying elevation, right, how high you're going. And the two units for altitude, if you take a look, they're right here, kilometers and miles on either side of the chart. By the time you get about 100 miles up, you're pretty much in the outer space realm, right, just where the atmosphere ends and space begins, roughly, okay? And again, that would be in kilometers on the left, miles on the right. Temperature is an interesting thing. So as you go up in the troposphere, as you saw in the movie clip, it gets colder. It drops down to minus 55 by the time you get to the top of the troposphere. But then, as you go into the next layer, it appears to increase. Okay? In the stratosphere, it appears to increase. That's called a temperature inversion. Where you get that colder air stuck beneath that warmer air there, okay? And of course, that gets down to negative 55 there, but when you get into the mesosphere, it drops again down to minus 90. I mean, these are insane temperatures, folks. That's in Celsius. Obviously, humans could not survive here for many reasons, one of them being it's too cold. And then once you get beyond the mesosphere, right, you cross that mesopause, that boundary, well, you guessed it, temperature starts to go back up. And it goes up beyond 100 degrees C, which is above the boiling point of water. And it's interesting, they say that if you could, hang out up there, which you can't, but if you could, many things would happen. First, of course, you would suffocate and there's not enough pressure and all that other stuff. But you would both kind of burn and freeze at the same time because there isn't much air, right? There aren't many air molecules, but the molecules that do touch your skin would be crazy hot, right? Over the boiling point of water. It would be like putting a cigarette out on your skin. But in the other areas, where there aren't air molecules, your skin is not touching air, it's just freezing. So you would get wicked frostbite and burnt at different parts of your body, depending upon if an air molecule bumped into you or not. Such a crazy concept, but clearly we are not cut out for life in any other layer other than the troposphere. Okay? These zones, if you notice, they are separated by those temperature differences, right? As soon as the trend changes, as soon as you go from down to up or up to down, boom, that's where that pause is, and the zone changes. Now, those pauses do fluctuate depending upon ground conditions, right? They can be a little higher or a little bit lower, depending on the time of day or time of year. But when that change does occur, boom, that is your pause. All right? Pressure, if you look at this line here, this is, you've all heard of the ozone layer. And roughly, that's roughly where it would be. It's in the stratosphere, okay? It is not in the troposphere. It's roughly about, just shy of 25 miles high. And the ozone layer, as you know, that's the layer that filters out all that UV energy that would totally give us skin cancer, okay? Up here, the beautiful aurora borealis, right? This is that zone of the atmosphere that occurs in. The mesosphere saves our butts all the time. That's where those meteors really start to burn up as the air gets thicker as you start to get closer to the surface, right? So that fireball is literally friction of that fast-moving meteor starting to hit the air molecules in our atmosphere and starts to burn up. The Concorde was an amazing commercial jetliner that would fly up in the stratosphere at speeds capable of like Mach 2, right? Twice the speed of sound. And they would have to monitor the amount of ultraviolet energy being absorbed because they were so close to that ozone layer. All right, they stopped flying it for many reasons, but it was an amazing plane. The scene you just saw, the Iron Man scene, of course, that was all in the troposphere. Okay, pressure, pretty straightforward. The higher you go, the less pressure there is. It's totally an inverse relationship, right? As altitude increases, pressure decreases. Until you get up to the top here, there's no more air, therefore no more air pressure, and everything just would expand. Okay? Okay. Who has more air pressure in this scenario? Marnie or Deanna? Well, clearly, Marnie has a lot more air on top, therefore more air pressure. Okay? Deanna climbed a mountain. There's less air on top, so therefore less air pressure on the person. And then, of course, water vapor, just like pressure, the higher you go, the less there is, and it does run out. Most of the water vapor is in the troposphere. And once you leave the troposphere, most of that water vapor is behind you. Commercial pilots fly right around here, about 35,000 feet up, and most of that water vapor is below them, and that makes flight much safer. Okay, that's pretty much the end of water vapor, right around 15 miles high or so. Okay, all right, so you have some summary questions, spend some time on those, and there is also a second page dealing with the chart as well. All right, I'll meet you back in a GC.